Assalamu alaikum warahmatullahi wabarakatuh. My dear student, our lecture today is specialized for first intermediate distinguished school. This lecture is about solving the question and the exercise of the lateral area and total area of cube and parallelepiped. So, first we have the question of make sure of your understanding, and we have an untyping error, which is repeat the question of the last subject, that meaning the first three question of make sure of your understanding in page number 44 will not solve it because it is the same question of volume of cube of parallelepiped of the last subject. So we will solve the next question, which is solve the exercise question number 4. He said in question number 4, a parallelepiped whose dimension are 3 centimeter parallelepiped its dimension is 3 centimeter and 5 centimeter and 6 centimeter. Calculate its or find its lateral area and total area. Here we have in this question directly applied of the lateral area and total area of parallelepiped to find them. As we said previously, the biggest or the tallest length is the length L equals 6, and the smallest one is the height. So the width will be 5 centimeter. Now by applying the law of lateral area of parallelepiped, which is 2 multiplying by length plus width inside the brackets, all multiplying by height. So it will be like this: 2 multiplying by length is 6 plus width is 5 multiplying by height, which is 3. Now 6 plus 5, 11 multiplying by 2, 22. 11 multiplying by 2, 22. 22 multiplying by 6 will be 66 centimeter to the power 2 is the lateral area of parallelepiped. Now we will find the total area, which is the lateral area plus 2 by L by W. Instead of finding substituting the law of lateral area and finding and simplifying and finding, we will substitute it from the previous step. Directly substitute 66 plus 2 by L, which is 6 by W, which is 5. 66 plus 2 by 5, 10 by 6, 60. So it will be 126 centimeter to the power 2 is the total area of this parallelepiped. Now I will solve the next question, which is question number 5. A parallelepiped whose base is square has edge. In question number 5, the parallelepiped, here we have the parallelepiped has a square base and it has length, meaning the square base, its length is 5 centimeter. Since the base is square, so all the length sides of base will be 5 centimeter. Why? Because the base, the square, all its sides are equal. So here we have the length and width are 5. Its height is 10 centimeter. That's meaning the height of parallelepiped is 10 centimeter. So here we have the length equal 5 and the width equal 5. Since they are the dimension of base. and the height is given in the question equal 10 centimeter. So to find the lateral area and total area, also by directly substitute, write the question, the law and substitute it. 2 multiplying by length plus width by height. 2 multiplying by 5 plus 5, all multiplying by 10. 5 plus 5, 10. By 10, 100. By 2, it will be 200 centimeter to the power 2. Now the total area will be the lateral area plus 2 by length by width. The lateral area is 200 plus 2 by 5 by 5. Now 5 by 5, 25, yes. By 2 will be 50. Plus 200 will be 250 centimeter to the power 2 is the total area of the parallelepiped whose base is square. Now we will solve the next question, which is question number 6. In question number 6, he said a parallelepiped whose lateral area is 49. Parallelepiped its lateral area is 49 centimeter to the power 2. Here we have the lateral area is given and its base parameter is 12 centimeter. Find its height. Here we have the height is unknown. And this question, he don't want to find the lateral area or the total area. We have the lateral area is given and the base area is 12 and the height is unknown. So we have a variable which is the height represented by h is unknown in the question. We have to find it. So we will use the law of parallelepiped since we have a parallelepiped and lateral area. So we will use the law of lateral area of parallelepiped, which is LA lateral area equal 2 multiplying by length plus width, all multiplying by height. Okay, now the height is unknown and the lateral area is given and the height is unknown. Since here we have length and width is unknown, are unknown, and we must have to find the length and width or 2 multiplying by length plus width, because we cannot find the height if we have more than one variable in the equation. يعني هنا يا طلاب عندنا المساحة الجانبية هي معطاة والارتفاع هو مطلوب بالسؤال. لذلك بقي لنا هذه الكمية مجهولة أو اللي هي 2 في الطول زائد العرض، لازم نجدها أو نعوض عنها مقدار معين، لأن ما ممكن إيجاد مجهولين بسؤال واحد. بما أنه هو هذا المجهول فهذا لازم يكون معلوم. And so since we have a law of lateral area, which is a lateral area, we can write it in this way: lateral area equal base parameter multiplying by height, where 2 multiplying by length plus the width is the base parameter. The base parameter. Okay, so the lateral area is 49 equal the base parameter is 12, which is all these value 2 multiplying by length plus width multiplying by the height. Now we have the variable which is h is unknown, so we can find it by solve it as equation, where we can divide it over 12 both sides. Why? Because the 12 is the coefficient of the variable. Then h equal 49 over 12. Here we have find the height of the parallelepiped which has lateral area is 49 and base parameter is 12. Now the next question, question number 7, we have a parallelepiped whose base is square, has height is 10 centimeter. So we have the parallelepiped with a square base. When we have a square base in parallelepiped, that means the length and width are equal. Okay? So in question number 7, parallelepiped length equal width, and they are unknown. Okay? And also we have its height of parallelepiped equal 10 centimeter. Here we have error typing. He said in the book it's total area, but we have an error. He gave us the lateral area. The lateral area equal 280 centimeter to the power 2. Then find the edge length of square base. Find the length of the square base. Since we have a lateral area and parallelepiped, so we will use the law of lateral area of parallelepiped. Then the solution will be like this. The lateral area of parallelepiped, 2 multiplying by length plus width multiplying by height. Here we don't have to find the lateral area because it's given in the question. We have to find the length edge of the base. And since the parallelepiped have a square base, so we have the length and width are equal. So the substituting will be like this. The lateral area is 280, 2 multiplying by length plus length, because length equal width, or multiplying by the height, which is 10. Here we have 2 by L plus L, any two same quantities equal 2 by the quantities. That's meaning L plus L will be 2L, all multiplying by 10. Then here we have 2 by 2, 4 by 10 will be 40, 40 L equal 280. Now we have to dividing over the coefficient of variable. Here we have an equation. We will solve it by dividing over the coefficient of variable, dividing both sides. The 0, 28 over 4 will be 7. Then the length size of the square base of parallelepiped will be 7 centimeter. Now we will take the next part, which is solve the problems. I will solve the question number 8, swimming pool. And number 8, I will read the question. A swimming pool whose base dimension are 4, the base dimension are 4 centimeter and 8 centimeter. 8 centimeter. And its height is 2.5 meter. Okay, now he told us the swimming pool is wanted to be paved with square piece of ceramic with edge length 0.2 meter, not centimeter, meter. Okay, now the ceramic, we want to pave the pool with a piece of ceramic with dimension or length, surely square piece with a length equal 0.2 meter. calculate the number of pieces needed to pave the swim pool. This is a question to find the number of ceramic pieces that we wanted or need to pave the pool. We have to find the area or total area of pool and divided it over the area of ceramic. Then we find or we get the number of ceramic that we need to pave the pool. طلاب، هنا السؤال المطلوب انه حوض ماء السباحة نعطيك ابعاده. ابعاد القاعدة اللي هي عرض 4 وطول 8 وارتفاع الحوض هو 2.5 سنتيمتر الارتفاع. زين، ويريد هذا الحوض يصفه او يعني يغلفه بسيراميك من الداخل، طبعا بقطع من السيراميك مربعة الشكل. طول ضلع المربع يعني السيراميك المربعة هو 0.2 سنتيمتر. يريد the number of ceramic piece that we needed or wanted to pave the pool. عدد القطع السيراميك اللازمة لرصف الحوض. فالحل يكون مثل ما شرحت لكم، بس راح ترجمها هسه، انه نجد المساحة الكلية مال الحوض ونجد مساحة قطعة السيراميك، كل قطعة من قطع السيراميك، فراح نقسم المساحة الكلية على مساحة السيراميك، راح يطلع لنا العدد اللازم، عدد قطع السيراميك اللازم لرصف الحوض. فانتبهوا الحل راح يكون كما يلي. بس انتبهوا the solution. Since we have the total area of pool is without the upper face. Why? Because the pool is the lateral face and only the down the face which has the sail of the pool. يعني المساحة الكلية مال الحوض راح تكون بدون الوجه الأعلى، لأن الحوض متكون من 4 صفاح اللي هي المساحة الجانبية مع الوجه الأسفل أو السفلي اللي هو يمثل أرضية الحوض، لأن الحوض ما بي وجه علوي. تمام؟ فهذا راح يكون the total area will be the lateral area which is 2 multiplying by length plus width or multiplying by height plus 1 of the bases not 2. بالقانون مال المساحة الكلية عندنا المساحة الجانبية زائد مساحة وجهين. هنا المساحة الكلية عفوا قاعدتين. هنا المساحة الكلية بما أن القاعدة العليا ما أكو، فراح تصير مساحة قاعدة واحدة، يعني مو 2L L في by width, only L by width. This is the total area or the surface area of the pool. By substituting 2 multiplying by the length is the biggest or the tallest length. This is the length. L equal 8 and the width is 4. These are the base dimension and the height 2.5. Okay? This dimension for pool, not the ceramic piece. So L will be 8 plus 4 multiplying by 2.5 plus L by width 8 by 4. Now multiplying this number by each other, we get 2 by 4 plus 8 will be 12. 12 by 2, 24. 24 multiplying by 2.5 will be 16. Plus 8 by 4 multiplying by 4 will be 32. 16 plus 32 will be 92 centimeter to the power 2 is the total area of the pool without the upper face or the upper base. Now we have the next step we have, or the second step we have to find the area. These are the total area of pool. Now we will find the area of ceramic, and since the ceramic is a piece of or square piece or have a square shape مع انه هو يحوي او شكل القطعة السيراميك مربعة. Then we will use the law of area of ceramic, which is L by L. مساحة المربع طول ضلع في نفسه. And the L here we have the length size is 0.2. Multiplying by 0.2, 2 by 2 is 4. And we have two digits, 1, 2.4. This is the area, sorry, meter, not centimeter. The area of each one of pieces of ceramic. Now to calculate the number of ceramic that we need to pave the pool, as we say, we will dividing the total area over the area of ceramic. That's meaning 92 dividing over 0.04, which is equal 92 dividing over 4, the total area over the area of ceramic. 92 dividing over 0.04. If we deleted the decimal fraction and added 20 in the numerator, نحذف الفارزة بالمقام، بما انه مرتبتين عندنا فنضيف صفرين للأعلى فتصير 9200 divided over 4 will be 2300 piece of ceramic that we need to pave the pool. The next part of this question, which is think, we have a question number 10, challenge. I'll read the question. We have a 45 parallelepiped wooden piece were placed together side by side. Each parallelepiped have a square base. Okay? We have a parallelepiped with a square base. Okay? Each one of these pieces of parallelepiped placed together, that we get this shape. Okay? 45 of these pieces placed together, then we get this shape. The dimension of one piece of parallelepiped is طبعا with square base, that meaning the length base is 2 centimeter, and since the base is square, then the length and width will be 2 by 2, and its height is 3 centimeter. This is the height of one piece. So here we have, if we place the 45 pieces of parallelepiped together, then we get the height of each layer is 3 centimeter. With a 3 centimeter, we have a 3 layer. Then each layer, the height of each layer is 3 centimeter, which is the height of parallelepiped piece. And we have the width is 2 centimeter, with the width of the second parallelepiped also 2 centimeter, with the width of the last parallelepiped, which is also 2 centimeter. Then the height of the figure, of the biggest figure of parallelepiped that we placed each one together is 3 plus 3 plus 3, then it will be 10 centimeter. And the width of the parallelepiped is 2 plus 2 plus 2, which is 8 centimeter. And since the base is square, no, here we have, since the base of parallelepiped is square, then we have the length also will be 2 plus 2 plus 2 plus 2 plus 2. Why? Because we have 1, 2, 3, 4, 5 piece of parallelepiped that placed together. Then the length of the shape of the biggest shape will be 2, 4, 6, 8, 9 centimeter is the length. Now he wants us to find the total area of the new geometric shape. The total area, we will use the law of total area, which is 2 multiplying by length plus width, or multiplying by height, plus 2 by length by width. By now substituting the value of new height and new width and new length, then it will be 2 multiplying by the length is 10 plus the width is 8 plus the height, by the height is 10 plus 2 multiplying by length, which is 10, by the width, which is 8. Now simplifying this number, 10 plus 8 will be 80. And 2 plus 2 by 9 will be also 80 by 80, plus 2 by 8 will be 16, plus 10 will be 116. Now 18 by 18 will be 324 plus 116. Then it is equal, the total area is 484 centimeter to the power 2 is the area of the shape after we place 45 pieces of parallelepiped with the 3 dimension. And here we finished our question today for finding the total area and lateral area of cube and parallelepiped, the geometric shape, cube and parallelepiped. Now thank you for listening and good luck.